8 Great Ideas in Computer Architecture. The 8 great ideas that the computer architectures have been invented in the last 60 years of computer design. These ideas are so powerful they have lasted long after this computer used them, with the newer architects demonstrating their admiration by imitating their predecessors. Number 1. Design for Moore's Law. The number of transistors in an integrated circuit doubles approximately every 2 years. Gordon Moore, one of the founders of Intel. As a computer designs can take years, the resources available per chip can easily double or quadruple between the start and finish of the project. Computer architects must anticipate where the technology will be when the design finishes rather than the design or where it starts. Number 2. Use abstraction to simplify design. In a computer architecture, a computer system is usually represented as consisting of 5 abstractions levels: hardware, firmware, assembler, operating system, and processes. In a computer science, an abstraction level is a generalization of a model or algorithm. Number 3. Make the common case fast. Making the common case fast will tend to enhance performance better than optimizing the rare case. Ironically, the common case is often simpler than the rare case and hence is often easier to enhance. This common sense advice implies that you know what the common case is, which is only possible with the carefully in experimentations and measurement. We use a sports car as the icon for making the common case fast, as the most common trip has 1 or 2 passengers, and it's usually easier to make a fast sports car than a fast minivan. Number 4. Performance via parallelism. Computer architects have offered designs that get more performance by performing operations in a parallel. Parallel computing is a form of computations in which many calculations are carried out simultaneously, operating on the principle that the large problems can often be divided into smaller ones, which are then solved concurrently parallel. Parallelism has been employed for many years, mainly in high-performance computing. 5. Performance via pipelining. Pipelining is a technique used in the design of computers to increase the instruction throughput, the number of instructions that can be executed in a unit of time. The basic instruction cycle is broken up into a series of pipelining rather than processing each instruction sequentially, one at a time, finishing one instruction before starting the next. Each instruction is split up into a sequence of steps so that the different steps can be executed concurrently by a different circuitry and in a parallel at the same time. Pipelining increases instruction throughput by performing multiple operations at the same time in parallel, but does not reduce instruction latency at the same time to complete a single instruction from start to finish, as it still must go through all steps. Number 6. Performance via predictions. To improve the flow and throughput in an instruction pipeline, branch predictors play a critical role in achieving a high effective performance in many modern pipelines. Microprocessor architectures. Without branch predictions, the processor would have to wait until the conditional jump instructions has passed the execute stage before the next instruction can enter the fetch stage in the pipeline. The branch predictor attempts to avoid this waste of time by trying to guess whether the conditional jump is mostly likely to be taken or not. Number 7. Hierarchy. Programmers want memory to be fast, large, and chip as memory speed often shapes performance. Capacity limits the size of problems that can be solved, and the cost of memory today is often the majority of a computer cost. Architects have found that they can address these conflicting demands with a hierarchy of memories, with the fast, smallest, and most expensive memory per bit at the top of the hierarchy and the slowest, largest, and cheapest per bit at the bottom. Caches give the programmer the illusion that the main memory is nearly as fast as the top of the hierarchy and nearly as big and cheap as the bottom of the hierarchy. Number 8. Dependability by redundancy. Computers that not only need to be fast, they need to be dependable. Since any physical device can fail, we make system dependable by including redundant components that can take over when a failure occurs and to help detect failures. Examples: system designers usually provide failover capability in servers, systems, or network requiring continuous availability. The used term is high availability and high degree of reliability. And that is the 8 great ideas in computer architecture. That is the end of my presentations. Once again, I am Redenter Foster. Thank you so much.